Hello, thank you. And so I will try to go to the end of my slides because there are a lot of them. We have only 25 minutes, so I speak fast, quick, and even if you don't understand, it's not a problem. The point is that I need to close this slide, okay? So, PostgreSQL control group. It's not container. I wrote container in the first place, but it's a bad idea. It's not container group, it's control group, something completely distinct. We will talk about that in a moment. So, I am Cédric Villemain. Maybe some of you know me. I know some of you already. Android for the others. I'm French. You can get that. I'm working in PostgreSQL industry or community for around 20 years. I started being involved in this area, working on T-Search, full text engine for PostgreSQL with Oleg and Theodore Sigev. I previously founded Second Current in France, and now I'm president of DataBene, which is a French company, but working worldwide for providing PostgreSQL expertise, support, and more PostgreSQL research and development, both for software and hardware research. So the agenda today is to go over the control group, what it is, get an introduction about cgroups with PostgreSQL, how it works, briefly, one big trade-off, some benefits still, and a possible roadmap. So control group, it's a Linux feature today. It exists in other operating systems, and some of the features came from Bull industry, so it predates a lot what was open source. It started around 20 years ago with version 1, and then it moved to be enhanced into version 2 around 10 years ago. Okay, so when we talk about cgroup, we're talking about version 1 and version 2, and always this is a question, so we'll look into this question just after. So what's the first thing, what's a control group? A control group is a solution, a feature from the Linux kernel to organize all processes, all PIDs, in a way that they are all in a tree, and so all of them have a parent up to PID 1. All of these processes are organized in a hierarchy, and so we're able to distribute and allocate or segregate resources on all this hierarchy using controllers. So the first question, because I've been asked for, please introduce control v1 and what it is and so on. But it's dead, okay? It's not deprecated, not 100%. But this is a recurring topic. The last one to point that were Oracle team at the Linux members just in September, last September. And again, the request was, let's drop that, please. But it's not done. So the agreement is to keep control v1 in maintenance mode. So there is some bug fixing, but maybe. What is very important, systemd has deprecated control group just 6 months ago, okay? And systemd is going to completely remove cgroup v1 support in their tool in the next release. And consequently, WSL, which is a Microsoft beast for that, has been updated in order to use cgroup v2 and to be able to drop also cgroup v1. So clearly, from my point of view, cgroup v1 is not even a question about comparing what they did, what they do, what they can do, because it's just outdated. If one man wants to raise your hands. You sure? There is a fan if you prefer. So, cgroup v2, that's the point. And, well, it's already running for PostgreSQL. You know, I'm introducing today something about PostgreSQL for control groups, but this job is done already. Sorry. So, look, this is a systemd setup, usual on a Debian machine, so I'm just starting my cluster. And then I'm able, with the control, you see this command, systemd cgls here. You don't see it, but you will see in a moment. Yes. Hop. Great. So this is a systemd command, which is very useful because it allows you to list the control group. And you can list from the root or mentioning a path name to the group you are looking at. So here, I just list the content of system slice, system PostgreSQL slice, and here is the content of the control group on my machine. which is a default setup like you have in your own servers, being Red Hat, Debian, or whatever, assuming it's not a 10 years old server. So clearly you see there is a control group, and there is PID and process. All those process and PIDs are in the same container group called system PostgreSQL.slice. Okay? It's not super rendering, but this is a kind of hierarchy of PostgreSQL, what I just showed before here, in the detail. So what's important is that in the hierarchy we have a first group, the system FS group. This is a file system mount, because there is a file system available with cgroup to make things easier. In Linux, it's very often that you just have file system to do in and out and configure things and get things. Exactly the same way for control group. So we have this main first group, yes?
If cgroup v1 is not deprecated yet, is it possible for both types of cgroup to exist on a system? And if so, how do I tell the difference in a cgroup listing?
Okay, yeah, it's possible to join both. You can have both hierarchy. You have some parameters to define to enforce which one you are using, okay? But the point that, as I just showed, many software just remove that, so you need to rebuild the software, activating some constant, some define, to ensure that you get the support for cgroup v1. If you're with old software, it's already working, so you can use both of them. This is called the unified hierarchy. So we can mix v1 and v2 to be able to address ongoing software.
Is there something different in the path or the name of the cgroup or some way? If I were looking at a listing, can I tell which one is version 1 or version 2?
I don't even know. Yes, very probably. Yes, because files are not always the same. I'm not sure to have the answer. Sorry. To be honest, it's a long time. I mean, I did not even look at the cgroup v1 layout since long time, so I don't remember. And so here we have in blue some stuff which are slice. It's important. This is not related to cgroup, not really, but systemd. Systemd has a root cgroup at scope, slice, and services. The slice has no PID. And so it's important because in cgroup v2, we cannot have an intermediary group with PID. So if you have a group who is going to manage subgroups, it must be empty of PIDs. So everything in blue here is without PID, so they can manage subgroup. All right? There is one exception for the first group, which is a root group and has some exception, but other than the one, all others, they must respect what I said. So at the end, we have this blue part, the slice, and the white part, which are services, and under services, you have PIDs. Okay? Scope, as for the init, can also get some PID. All of that is completely arbitrary. This is name we define ourselves. Cgroups themselves, they do not insist in naming or whatever. Not a lot. And so you see at the bottom, the process that we were looking at on with CGLS. Okay, the same one. Cool? Okay. And here on top, you see SSHD with its PID. So, on the Docker, exactly the same thing, okay? You can look, the bottom is exactly the same thing between this one, which is systemd, and this one, which is a Docker. So, same thing. It's running in control group v2 too. Docker also is improving and is now providing control v2 by default for the same reason like others. Okay. And the big question is Kubernetes. Okay. Well, if you're still using Kubernetes, the kubeadmin recommends systemd cgroup driver because kubelet is managed by systemd, and Kubernetes is just a framework on top of Docker. And since Kubernetes 1.22, systemd is default cgroup driver. Okay. Remember, systemd is going to deprecate and drop cgroup v1 in the next release. So you see the impact for others around. They are going to move. Output is similar to Docker. So I believe we can have an agreement here. cgroup v1 should not be used. All over the place, PostgreSQL is running inside cgroup v2. Every time, everywhere, always. Maybe not on satellite, maybe not on some exotic solution, but 99%. So starting from now, when I say cgroup, I'm saying cgroup v2. Okay? So, what is this talk about? Because this is done already. So here the point is to get more from that. What if we have cgroups? You know, more than one. Look. Hey. This is not the same thing as before. This is CGLS again, but on a custom patched PostgreSQL, where I define groups and controller group. So here we define a critical controller group, here. And we define one for the workload, for example. And so every time there is a dash, this is a group, a control group. And when there is a PID, this is just a process, so this one is not a group, okay? But with this is easy to allocate process to each kind of workload and each kind of activity that you want to address. That's so nice that, there is two other groups, auxiliary and maintenance, okay? This is arbitrary, we can choose that, change that in the future. And for instance, the IO workers, I didn't investigate into them yet, so I just put them in auxiliary services. The other point is very visual, is here. So is it real? Oh, God. This is not CGLS, this is CG top. So this one is controller group top. It's going to top for each of your container group under the path name that you provide on the command line, okay? So under this path name, there is all those groups in a hierarchy. So the first one, here you see, it has 23 processes. This is the sum of all the processes under it. And it's consuming 320% CPU. This is the sum of everyone inside. And the same for memory, and same for input, and same for output. Okay? So it's really super nice. We have a lot of metrics, really. And this is a real screenshot. But the output is not correct, because look, for the IO workers, there is nothing. And if we look at background writer, here it's empty, and here it's empty too. It's because the controllers are not pushed down to those groups. It means, for example, that currently the background writer and the checkpointer, as well as the IO workers, they do not have a control available to look at IO or memory they are using. Only the group which is the parent of those as the controller and is able to get the information. The subgroup is not, and so cannot access. As a result, when you look at CGTop, we can believe that IO worker is doing nothing or background writer is doing nothing in IO. It's not true. It's just that it's not visible in this view. So be careful here. So, well, all it works with just an extension, more or less. So we don't really need to patch PostgreSQL yet. But still, it's really harder to achieve. We can do that with an extension. We need to reassign things after the fact, and we do that from an external point of view, I would say. So it will be much more easier if we have a patch inside PostgreSQL, because when we want to create the first C group and we want to allocate PIDs, it's okay, but we cannot have a C group which has at the same time PIDs and subgroups with PIDs. So we need to address that when we start the server, or if we do that after the start, we need to reorganize every PIDs in order to be able to put the hierarchy we want. So it's more complex to do that after the fact. Doing that when PostgreSQL is starting is super easy. Also, it's less efficient, because if we do this way, we have to reassign using fork, where instead we can use clone and assign directly to the right C group. And when we use a clone system call, we can also say, well, I don't want to share memory, I don't want to share file descriptor, or whatever I don't want to share. So maybe it's also a good future for PostgreSQL. And also the fact that this is an extension, it limits the features. For example, with control group, it's super easy to kill all the process at once. Just have one syscall, and boom, everything down. We don't have to loop to kill all the backend when PostgreSQL is crashing. It's useless. We can do it all at once. It's safer. Some stuff are less safe, probably, as an extension, but I'm interested in them. For example, from extension, reassigning the PID is not really super nice. I mean, reassigning the Postgres PID when it has already started and is already subject to latency, maybe not something we want to do too much. We need to get poor PR which is a way to get the information from a kernel about the events, the pressure, to be able to react to the pressure. We can do that from extension, but if it was inside a wait event into PostgreSQL, much easier to use. Another less safe things, freezing process. With cgroup, you can freeze process and you can resume them. You can freeze a backend and you can resume a backend. You can preload a backend, freeze a backend, and resume the backend when you want to connect to it. But it's easier to do from PostgreSQL core. And the same way, we can do throttling with this and eBPF, but for the same reason, it's much easier if you control that from the PostgreSQL core, because PostgreSQL itself is doing some throttling, and you don't want to collapse with what it's doing. So, some rules of control group. One PID can be in only one cgroup at a time, okay? And one PID only can be migrated at a time because we use write system call, and the write system call has just one single error, success or error, so we can pass only one PID, so we know if it works or not. All processes inherit restriction from the parents. They do not inherit everything, but if you limit a parent to 10 gigabytes memory, the children won't get more than 10 gigabyte memory, okay? So everything runs in a cgroup today. So this is the point I outlined, but very important. PIDs can only be in the root cgroup or in leaf cgroup, not in the middle. Okay? And I go faster because it's time limited. Controllers. And the controllers are really the way to expose things and to control things inside control group. Okay? And those are some of the defaults which are probably the most interesting, at least for me. One is the CPU. So you can define what you do with CPU. You can also get metrics. And you can get the pressure event, you can define burst and wait. So you can say, hey, my logger is less important than my backend. My background worker is less important than my backend. My checkpoint worker is more important than my background worker. And so on and so on. The CPU set, super nice. You can bind to CPU. There is no more issue with NUMA. When you connect, you assign just your backend PID to the right NUMA node. You can control that. It's super easy. Say you have all your database, you have 10 databases. Maybe you're going to segregate, say first database go first to NUMA node 1, second database go first to NUMA node 2, and so on. And so it's ending the double cache, and maybe much more easier than addressing this kind of problem from the strong PostgreSQL source code. The freezer, which I mentioned, is very interesting. So you can freeze backends, connections, and resume them very quickly, much faster than forking or anything else. If you're using BTRFS, you can benefit from a QoS on I/O. It's working only with BTRFS. It's written in the doc that you have I/O and everything, but only the pressure is supported for most of the file system. Other than that, it's only BTRFS because all of that has been done by Facebook, and Facebook is using file system BTRFS. And the last one, which I believe is important, is the memory one. So you get access to userland memory, to the kernel data structure, to the TCP socket buffers, and for all of them, you get the pressure, like for I/O and like for CPU, super interesting. And you get the OM group. The OM group, if I find my mouse, well, sorry. Here, this one is a point which allows to kill all the cgroup at once. Okay, so if we go back here, here, say I want to kill all the auxiliary at once, it's possible. I want to kill all the backend at once because I fear that I keep using the shared memory and I don't want that to happen. I can kill all the workload if I want. Okay? And there are other controllers. It's not the full list, but just device memory, huge tables, remote DMA, which is not yet in PostgreSQL, but I strongly hope that we're going to move forward in this area because this is super important for the future. And maybe the most interesting one, the last one, eBPF, because this BPF is very binding to cgroup. And it's easy to write an eBPF type program for cgroup and to hook on the path name to be informed of what's happening on the cgroup. In the same way, ongoing discussion for eBPF are to bring PSI, precious state information primitive, back to eBPF. So eBPF programs can be signal about event from the kernel and address pressure and react to that. Much faster than an external process and sandbox it into the kernel. Probably the safest solution. The only issue, eBPF requires root. The trade-off. Okay. Unfortunately, well, I expected to not have to show this slide, but we still have time. So the trade-off, this is from the Linux documentation. And so it's very strong, but it's only for the write back, okay? What it's saying is that cgroup management and accountability of I/O and memory requires you to know who is accessing the page. And by default, you can just use the owner, the first one who started on a page of memory or I/O. So if I request in memory and others are using the same memory, I'm going to be receivable for that. And it's not 100% true with what is written, because at some point, if neighbors consume more memory than I do myself, then there's going to be a context migration of the accountability to the next cgroup, the one who is consuming more than us. So doing in and out is also a risk, and there are some tuning to be able to prevent that to happen, and so on, and so on, and so on. So you remember the real screenshot? Misleading output, because the I/O and the memory we throw in the screenshot maybe are correct, maybe are not. Because in the cgroup I set up, I have distinct cgroup for I/O workers, for background workers, and for backends. And maybe accounting has been done to the backend, but maybe it was a background worker, a writer who was writing. We don't know. It's misleading. We need to be careful here. I hope it will be much better with I/O ring. I don't know, I didn't evaluate it, the beast, but very probably I/O ring allows us to really put together all the backends which are already doing I/O in Postgres. So, how it works? It's quick, easy. There is delegation to have from systemd. So you are able to address control group into your own process, here PostgreSQL. You create a new cgroup. This is super easy. You just make a dir or use dbus. Dbus is complex, but make dir is very simple. So you make a dir into the hierarchy, and boom, you have created a cgroup. Very easy. Then you migrate process. Migrating a process, just say echo my PID to my new cgroup, and boom, the process is migrated. Now that my original cgroup is empty, it becomes a slice, and then I can create my other group and manage whatever hierarchy I want to have. Any new fork from this first process or for other process will stay in the group where they're coming from. If my parent is in my group R, then the fork will be in group A by default, and then it can be migrated to another one with fork. Or we use clone, and we clone directly in another group. And boom, we're done. So setting up control groups is very easy. It's really not a problem. The problem is not here. So what can we improve? First, I believe that it will be super interesting to just remove fork and use clone instead at a minimum, or to review how we fork process into PostgreSQL, because this is just a nightmare. It allows us to do nothing except just burying cycles and memory and everything. I define some default cgroup: critical, workload, startup, maintenance, auxiliary. You can name your own. We can do that distinct ways. There is something to improve. I don't know what are the good choice yet. And also, maybe it will be interesting to get a GUC interface for all of that, and maybe offer the users to assign databases to some cgroup, so you can really define resource management per databases, for example. And the last point, ePOL-PRI, which is a support for resource control. And so getting that into wait event set wait block allows anyone to poll the resource and to be informed about what's going on the machine for a small cost. So, why is it interesting? Yeah, I'm closing. What I suggest, we have 4 minutes left, so if you have questions, please raise your hand. Question, because we have maybe 3-4 more slides, that's all. Yes, go on.
So, looking at your original group, automatic launcher, your critical.
Yep.
Looking at your original layout, you've got auto vacuum launcher in your critical set. auto vacuum processes probably shouldn't be in that critical set.
Oh, yes.
Where would you book it in?
Hey, this is a good point, but I have an explanation. Here. Well, it's visible here. Here I put the vacuum launcher. But I put the auto vacuum workers in a maintenance group. I decided arbitrarily that the vacuum launcher was critical.
Yes.
And the vacuum workers were in another group. They're going to be spawned in another group and reassigned in another group. In maintenance group.
Where's that control? Is that something that Postgres code has to get involved?
Yeah. At the moment, you can do from external point of view, but I did that with a patch. And so in PostgreSQL, we can assign. If it's a fork, we need to reassign. Because even in PostgreSQL, when you fork, we don't know exactly what we do. Okay? This is just fuzzy. Then later, we can have clone and say, OK, this is my auto vacuum launcher. When it's spawned into maintenance group directly. You're welcome. And so maybe just to end on that possible roadmap on these topics is to use out of core extension. Many exist already, and we have some. I would like really to be able to reassign PID in core, so keeping fork at the beginning, and then moving fork to use clone, and then adding poll PRI to wait event, and then providing a core interface for extension to tune cgroup, because the best thing is to not do that into PostgreSQL. It's super complex. Defining a policy, resource management, don't do that. Preferring offering an API, let extension discover what's good and what's not, and then in 1, 2, 3, 4, 5 years, we maybe will have some policies internal to PostgreSQL. And I'm going to shut down the mic. Thanks a lot.